Assalamualaikum and hello everyone. My name is Hanif Hidayat bin Rosli, and today I'm gonna run lab experiment 4, which is simulating precipitation using visual Minteq. Okay, so the task, an electroplating with water contain 1000 milligram per liter of cadmium and 1 molar of H2SO4, and the on-site physicochemical wastewater treatment plant use lime to neutralize the wastewater and precipitate cadmium. So the first task is using visual Minteq, predict the pH and species distribution in the wastewater before addition of lime. Copy the pH and species to Excel. Okay, so open the visual Minteq and then we go set the parameters and various default setting. So the first one we click no, and then we go to 5000 and then 0.3 and Davis. Okay, so the next one is solution, and the last one is oversaturated solid are allowed to precipitate. Each time a mineral precipitate or dissolve. Okay, so then save and quit, and set the pH to calculate from mass and charge balance, and then include the component name H plus and 2 molar. So add to list, and then we add component SO4. So the total molar is 1 molar. So add to list, and then we change the concentration unit into mgl, and then we go to the component and choose CD for cadmium. Okay, then so we go to the total concentration is 1000 milligram per liter. So view or edit list, add to list and change the unit to molar. Okay, so we go to the view and edit list, and then we round off the total concentration into 2, and the SO4 is 1, and back to main menu, and then run Minteq. So after that, we get the pH after addition, which 0.092, and then copy the value and paste on the Excel for before addition of CaOH 2. So the pH that we got is 0.092. And then we go back to Minteq. So view species distribution. And then we highlight the total concentration and species name, copy, and then back to main output menu and open the Excel and paste on the Excel. Okay. After that, we have finished the question number 1 and go to the question number 2 using visual Minteq. Titrate 1 liter of wastewater with 1 molar of CaOH. Choose suitable titration step. Export the result to Excel. Okay, so we open the Excel, the Minteq, and press back to input menu. And then go to multi-problem sweep. Okay, so click right on the titration box and go to the titration manager, and we include 1 liter of wastewater and 0.02 of titrant, and we need to click on the box, and then we add titrant Ca, and then 1 mole per liter, then save and next, and then go to save and back to multi-sweep menu. Okay, so after that, when we got the 1 liter of wastewater, we need to titrate with 0.02. So we get 50 step, and then I add with 50 step, another 5 steps, so I will get 55 steps. So and then I choose CD, and then total dissolve, and then add, and then save and back. After that, run Minteq. So after that, I will go to the Excel and select, then press selected sweep result, and then copy all the data from problem of number to the cadmium total dissolve, and then highlight to the bottom, and then just copy all the data and paste into the Excel. Okay, then so after that, we move the 2 column, move to the right. So we move to the right, the one column next to the existed column to add volume. So okay, we will need, it will take several times. So just keep waiting and then okay. So we choose the two column and move it to the right. Okay, so at the we add the column of volume of CaOH. So the volume of the titration starting with starting with 0 and then 0.02. So in order to get the fastest result, we can highlight 0 and 02 and then just click at the bottom. So drag until the bottom. Okay. So after that, we name it the column as pH and the unit is dash, and then C total dissolved CD concentration mole per liter. Then after we got the table, so we need to plot the volume of CaOH, the pH and total dissolved, and format the graphs professionally. So highlight the data of from volume until the total dissolved and highlight it into their bottom. Okay, so go to insert menu, go to insert, it may take several times. And then we choose the graph and scatter, choose the first scatter. And then we need to format the graph and we choose, we need to remove the guideline, grid line, chart title, and then we need to go to the, and then we change the color of the font. Okay, so after that we click on the data, on the plotted data, just double click, and then it's just one, just close and do it again. until we get the yes. Okay, so secondary exists, and then we choose to black the color, and then for the line, of course, we need to fill with the black color line, solid line, black color, and do the same for the another two axis. And then we just axis title, and we need to adjust the size of the graph so that it will fit the title of the axis. So this one is pH, and then okay, so this one is volume of CaOH, and the last one is total dissolved cadmium concentration mole per liter. Okay, then we just color the text with black, and series 1, and then in order to answer the next question, which is using the graph, identify the volume of 1 molar CaOH required to neutralize the 0.1 liter of wastewater. Okay, so go back to the Excel and insert the shape, and then go to the line. Okay, so the neutral pH is 7, so between 8 and 6, and then just draw it straight line until the part of the neutralization, and then so we add another line from the end first line into the bottom. Okay. So I need so we need to click the format shape, and then go to the color red, and then the width 1.75, then dash type, go to the okay, that's this one. Okay, then another line, you just repeat the same procedure, which is up the width to 1.75 and then go to dash type. Okay, this one, go to red, and then we have the answer. So in order to get the answer, we find the pH from 2.2 at volume of 0.98 to 1, it increased to 11.233. So this means the pH 7 is between those two volume of CaOH. Okay, so this the data. In order to do the interpolation, we copy the data, interpolation, and then wait. And then this one is X. We assume as X, and this one we 7, which the neutral pH value. Okay, so to interpolate, we get X equal, we press equal and open the bracket, and we click 7 and minus 3 2.7 2.242, and then we close the bracket, and then we times by 1 minus 0.98 and close the bracket, and slash 11.233 minus by 2.242, and then we close the bracket, and then plus 0.98. Okay, so we get the answer, which at the volume of 0.991, it will neutral the solution. Okay, so after that, we get 0.999, and then we need to, we have the volume 0.99 liter and times to 1 mole per liter of Ca, and then okay. So after that, we go back to Visual Minteq, reset, and add again 1 molar of H2SO4, 1000 cadmium, and the amount of CaOH required to neutralize the wastewater. Okay, so press reset and go to the pH and choose just like before, and then add H plus and 2 molar, and then add to list, and then SO4 1 molar, and then CD, change the unit to mg per liter over 1000, and then add to list and change back the from the concentration unit, and then we add Ca at 0.991 mole, and then add to list, and then we view and edit this. So in order to get the H1 is 1. It's actually 1.009 because we minus the Ca and the OH minus component, so we will get the value of H1. So the value of SO4 is 1, and then back to main menu, and then run Minteq. Yes, run Minteq. Okay, after that we got the pH. After addition of, to copy the data and then back to Excel, and then this the after addition of 0.991 CaOH2. Okay, so the pH is pH 3.979, and then go back to the Minteq and press the display saturation index, and then we choose the gypsum since it shows the green value. Okay, so we click amount finite solid and we copy the gypsum and then paste on the Excel. Okay, so the unit is mole per liter, and then in order to find the mass concentration, we need to find the molecular weight. So the molecular weight for gypsum is 172.17 gram per mole. One hundred 72.17 gram per mole. So we get the mass concentration, which is gram per liter. So we got 0. Okay, highlight that one, and then times by the molecular weight. So we got the answer. And then the task number 7, we need to the convert the molar concentration, and we need to convert into GL and calculate the mass of heavy metal sludge in kg produced per meter cubic of wastewater. So we need to change the unit from gram per liter to kg per meter cubic, and then we just highlight and then we go to the answer and then paste, and then we times by 1,000/1,000 in order to get kg per meter cubic. Okay, so that's all from me, and thank you.